Hello everyone, welcome back. The last lecture we have done conservation of momentum, and today I will do some numericals based on this conservation of momentum. So this is your question number first. Question number 1 says, a bullet of 5 grams is fired from the pistol of 1.5 kg. If the recoil velocity of the pistol is 1.5 meter per second, you have to find velocity of the bullet. First thing to do numerical is to draw a picture of this. So what you have is a piston. Let's say this is a piston and this is bullet. Now the mass of bullet is 5 gram. Everything you have to convert in standard unit. So 5 divided by 1000. So it will give me 5,000 kg. Okay. And then it is fired from pistol. The mass of this pistol is 1.5 kg. And recoil velocity of this pistol is 1.5 meter per second. In this direction, you have to find velocity of bullet. So VB you have to find. In this type of question, you can take either initial momentum as 0 by considering that initial system was at rest, or you can take final momentum as 0, considering in the end they will come to stop. So here I am taking initial momentum of the system as 0. They are at rest. So initial momentum is equal to final momentum, that you know. So let's say this is your MP UP plus MP UP. This is mass of pistol, initial velocity of pistol, mass of bullet, initial velocity of bullet. Similarly, this is your final momentum, and this is VB we have to find. So this will goes to 0. Now simply you have to put the numbers in this. Mass of pistol is 1.5. So 1.5 into initial, this final velocity of the recoil velocity is 1.5 plus your mass is 5,000 into VB you have to find. Now if you see, this is simply a linear equation that you have to solve to find variable VB. So numbers I will take on one side. So if I take this, it will become minus of 1.5 into 1.5 equal to 5 by 1000 VB. Or I can write this equation as VB equal to minus 1.5 into 1.5 into 1000 divided by 5. When you solve this, you will get minus 450 meter per second. That means velocity of the bullet is minus 450 meter per second. Now negative signs mean the recoil and the velocity of the bullet. The recoil and bullet, they have opposite direction. Now coming to the second question, we'll write this and do here only the second question. The second question says, two objects of mass 1.5 kg are moving in the same straight line but in opposite direction. The velocity of each object is 2.5 meter per second. Before the collision, during which they stick together, what will be the velocity of the combined object after collision? That means, let's say these are the two objects. They are moving in same straight line but in opposite direction. Same mass, same velocity. They come here, they collide, they stick, and now after they stick together, you have to find velocity of this system, this combined system. So first thing, we will draw a diagram, two objects. Let's say this is your A and this is your B. Masses are same, 1.5 kg, 1.5 kg, and both are moving with same speed, 2.5 meter per second, 2.5 meter per second, but they are in opposite direction. After that, they will collide and they stick, and now after they stick together, you have to find velocity of this combined system. Now in this type of numericals, if you think little bit, there is no need to do all this calculation. They are of same mass, with same speed they are moving. When they stick, they will stop. And the same thing we will see here. So initial movement of the system, MAUA plus MVU. Now for the final one, they stick together, so they will have combined mass. So MA plus MB, and now this combined velocity VAB you have to find here. So now simply put the values. Now one more thing, because they are moving in opposite direction, So one of them you have to take is negative direction. So I am taking B, A as positive and B as negative. So you have to put minus sign. So why you have minus sign? Because the two are moving in opposite direction. Now simply put the values 1.5 into 2.5 plus minus is minus 1.5 into 2.5 equal to 1.5 plus 1.5 VAB. These two terms, they are equal and opposite. So this is 0, this is 3, VAB. 1.5 is 3. So VAB is 0. So after they stick together, they will come to stop. Now after these two questions, we will do third one. So third question says, a 3 kg fish is swimming at 1.5 meter per second to the right. It follows a 0.25 kg fish swimming to the left at 4 meter per second. What is the speed and direction of the larger fish immediately after the lunge? So there are two fishes, they are moving in opposite direction. Let's assume this one is the bigger one and this one is the smaller one. So they moving this like this and it follow this and then it move. You have to find speed and direction of this larger fish after the lunge. So first thing, make a diagram. So this is your bigger fish. Mass of this is 3 kg and it is moving with 1.5 meter per second. And the crazy small fish, it is here moving towards this big fish. Mass is 2.5 kg and it is moving with 4 meter per second. So then they come very close to each other. This big fish, it will eat smaller one. And now for this combined system, you have to find velocity. So same thing, initial momentum equal to final momentum. So initial momentum, I am taking this as A and this as B. So MA UA plus MB UB. Because now the system is combined, so MA plus MB, this is combined, you have to find. Now simply one more thing, because they are moving in opposite direction, so you will have a negative sign. So I will simply put these values. So 3 into 1.5 plus minus is minus, and this is 0.25 into 4, which is equal to, and the masses are 3 plus 0.25 VAB you have to find. So this is 4.5 minus 1 equal to 3.25 VAB. Or my VAB is 4.5 minus 1 is 3.5. So 3.5 divided by 3.25, that will give me something around 1.07 meter per second. So the bigger fish will move in the right direction with velocity 1.07 meter per second, smaller than what it has earlier. So after eating food, have it move little bit slower. Now question number 4. Two objects of masses. So this question number 4 also I will do here. Okay. So two objects of masses 100 gram and 200 gram are moving along the same line and direction with velocities of 2 meter per second and 1 meter per second respectively. They collide and after the collision the first object moves at velocity of 1.67 meter per second. Determine the velocity of the second object. Now imagine this numerical. So let's say these are the two objects. They are moving. One is 100. Let's say okay, this is 100. This is 200. This is little bit faster. So they are moving like this. And after some time, both is faster. It will collide with this. And now again, two will move with some velocity. Velocity of A is given after collision, but B have to find. So after collision, there will be some interaction. The velocity will change. To change the velocity of B, you have to find. First thing, I will draw a diagram. So this is your A, this is your B. So this is your 100 gram, which is moving with 2 meter per second. This is your 200 gram, moving with 1 meter per second. So first thing, convert this into kg. So 100 divided by 1000, 1 by 10 kg. Similarly, 200 gram means 2 by 10 kg. Both of them are moving in same direction. are not taking into consideration this angles. That you will do in higher classes. Now this after collision A will move with velocity of 1.67 meter per second. This VB you have to find. So now MA, same conservation of momentum equation. Now because they are moving in same direction, so you don't have any minus sign here. Simply put values. So 1 by 10 into 2 plus 2 by 10 into 1. This is 1 by 10 into 1.67 plus this is your 2 by 10 into maybe. Again what you have is linear equation. This is what you have to solve. So this will become 4 by 10, 1.67 divided by 10 plus 2 by 10 VB. Because 10 are common. So this 10 is in denominator of all three numbers. So this I can remove. So I will left with this equation. This is here like this, and when I solve this, 4 minus 1.67 equal to, this is your 2. Or your VB is, separate this 4 minus 1.67. So 4 minus 1.67 divided by 2. So find it out. You will get your VB. It will come around 1.165 that you can solve this. Okay, so these are the 4 numericals. There are some more numericals given in your book. Try to solve them using same concept. Now, in today's document, I have included some words also. Very interesting. They are very interesting. Just read them and try to solve them. One of the words is that is. Let's assume that there's around 1 billion population of China. Okay, so if they jump all this 1 billion people, let's assume their mass is 60 kg. If they jump simultaneously, then, so when they are jumping, they are coming back, they will, what will happen? There is conservation of momentum, so this earth will also recoil. So this recoil of earth you have to find. And then try to solve this using same concept. One more question is there. In one of the movie, Eraser, I don't know if you have seen or not. In that movie, the hero, he uses some very high-tech technology weapons. So that weapon, it emits bullets or rays, you can say, with speed of light. Now the hero is standing and he is emitting out those bullets. He is standing still. Is this situation physically possible? That you have to think and write. And please submit those numericals